Hello everyone, in this video I am going to show you an easy shortcut to find a to the power of n. That is, to find a to the power of n, if a is a square matrix of 2 by 2, we can use the characteristic equation a square minus trace of a plus determinant a into I is equal to 0, where this trace of a means sum of the main diagonal elements. The question given is, if a is equal to matrix 5, 3, 7 and minus 5, then find the value of a raised to 500. Therefore, to find a raised to 500, we can use this shortcut. Here a is a 2 by 2 matrix and the characteristic equation is a square minus trace of a plus determinant of a into I is equal to 0. Now calculate trace of a and determinant of a. Therefore, trace of a is equal to sum of the main diagonal elements, that is 5 minus 5, that is equal to 0. Now determinant of a is equal to, calculate the determinant, negative 25 minus 21, that's equal to negative 46. Now just apply the values here. Equation is a square minus trace of a plus determinant of a into I is equal to 0. That is a square minus 0 plus determinant of a means negative 46 into I is equal to 0. Just to simplify the equation here, we have a square is equal to 46 into I. Now question is a to the power of 500. So just calculate the power a square to the power of 250. So a square to the power of 250 is equal to 46 to the power of 250 into I to the power of 250. That is, a to the power of 500 is equal to 46 to the power of 250 into I to the power of 250 means I itself. So 46 to the power of 250 into I. Therefore, this will be the final answer. Let's try another example using this shortcut. The question given is, if a is equal to determinant negative 2, negative 1, 5 and 2, find a to the power of 780. 4 options are given: I, 2i, 3i and 4i. Here also a is a 2 by 2 matrix, so use the characteristic equation and solve it. So first calculate trace of a. Trace of a is equal to negative 2 plus 2, so that's equal to 0. Now calculate determinant of a. Determinant of a is equal to negative 2 into 2 means negative 4 minus 5. So that's equal to negative 4 plus 5, that's equal to 1. Therefore, simplify here, a square minus trace of a. Trace of a means that is 0 plus determinant of a means it is 1 itself. So 1 into I is equal to 0. So we can write a square is equal to negative I. Here we need to find the value of a to the power of 780 and we got a square is equal to negative I. So to get 780, we need to multiply the power with 390. So a square to the power of 390 is equal to negative I to the power of 390. And this negative I to the power of 390 means it is I itself. Therefore, a to the power of 780 is equal to I. Therefore, I is the final answer. Let's try one more example. Given question is, if a is equal to cos theta minus sin theta and sin theta cos theta, find a raised to negative 50, where theta is equal to pi by 12. Options are 2i, 3i, I and 4i. Here a is equal to cos theta, negative sin theta and cos theta. Here when we calculate trace of it, here cos theta and cos theta is not equal to 0. But in the opposite direction, we can see this is sin theta and negative sin theta, it is 0. So just to interchange the elements, that is interchange the rows and find a. So a is equal to sin theta and cos theta and minus sin theta. First row R1 changes to R2 and R2 changes to R1. Now when we calculate trace of a, we will get sin theta minus sin theta, that is equal to 0. So our calculation will be easy. Trace of a is equal to 0. Now second, we need to calculate determinant of a. Determinant of a is equal to, we rearranged a like this. So here sin theta into minus sin theta is minus sin square theta minus cos theta into cos theta, cos square theta minus cos square theta. And we have sin square theta plus cos square theta is equal to 1. So that's equal to negative 1. Just apply the equation a square minus trace of a plus determinant of a into I is equal to 0. As you can see here, we have trace of a is equal to 0. So just give the value 0 here. Therefore a square, this is 0. Last term is determinant of a into I. So minus 1 into I is equal to 0. That is a square is equal to I. Here the question is to find a raised to negative 50. So to get negative 50, we need to take the power as multiply with the negative 25. So a raised to negative 50 is equal to, here the RHS is I, so I to the power of negative 25. That is I to the power of negative 25 is I itself, so equal to I. So we can write a to the power of negative 50 is equal to I. That is option number C is the correct answer. A raised to negative 50 is equal to I.